So we are going to use Python. Somebody will say, Andriy, what are you talking about? Python is not suitable for the task. We are going to process sound real time. Python is too slow for it. Yes, it's true. But we are going to use Python for the same reason it used in a computer science, machine learning and the rest of the heavy tasks. The thing is, Python can run libraries that are completely written in C, and all the hard work delegated to the compiled, performant, low-level code. And we have these beautiful people who do a huge open source work for us. The framework we are going to use called Pio. So, Pio. It's a bunch of tools for the real-time audio processing and for sound synthesis. Synthesis. If you want to know about the framework, there are many examples in the documentation. Just go through them one by one and you will know it pretty good. I highly recommend Pio if you're interested in synthesis. The API is great, but we will touch just a tiny bit of it here. Let's get to code. So I've set up the virtual environment for the project, and everything that I have here is just Pio. Here it is, it's version 1.03, and all the rest packages just dependencies for the Pio. So let's import the Pio itself, and to start with it we have to create a server. Then I will set up my input and output. If you don't have any external audio interface, you don't need this. If you don't set anything manually, Pio takes the default system settings. This is the number of the input. And how I know that it's 3, Pio has a special method to print all your devices. Let's run the code. And as you can see, I have a bunch of stuff here. And here we can see that 0 is my built-in microphone, 1 is the standard laptop output, and here is my audio interface, which has number 3 for in and number 3 for out. This is how I know what to put here. And I'm also going to use a MIDI controller for the project. Now we have to boot the server, and then I want to catch up my mic, so everything that gets into this mic I want server to be able to process. For that we create a new variable, we catch the input and we route it to the output that is set up here, and then we start the server itself. Also, I want to have GUI. Pio has a bunch of visual tools that we can use. For example, if you don't have a MIDI keyboard, you can use a GUI version of it. So you will see the keyboard on your screen, and when you will press the buttons with your mouse, it will behave like a MIDI controller. So let's run the code, and here we can see the visual interface of our server. We can stop it, we can start recording, but for now we just want to play the note and hear it in our speakers. Okay, it works. And now I want Pio to take the note that I play and play another note in 4 semitones from the original. If you don't understand what I'm talking about, please check the previous video of the series. There is an information about why we take 4 semitones and so on. Pio has a special class to pitch the notes. It's called Harmonizer. How it works? It takes the input, in our case it's our microphone, and transpo is the amount of semitones that we want to move the new note in comparison to original. And as with the microphone, we use the out method. We will hear the microphone, the original note, and also transposed note. Let's test it. As you can hear, 2 notes are playing now. Remember this GUI thing. If I will run this method for the harmonizer, we will have this beautiful interface. I will play the note and I will change the pitch of the second one real time. Cool, right? And now let's build the chord. So I have 3 notes. The first one is 4 semitones higher than the root. The second one 7 semitones higher than the root, and the last one is 11 semitones higher than the root. And we will hear 4 notes. 1, 2, 3 and 4. Let's run the code. Complete major 7 chord. And now what I want is to, when I press this pad, I want it to play me a major 7 chord. And when I press this pad, I want to hear a minor 7 chord. And when I play this pad, I want to hear a dominant chord. And the last one is for the half diminished. The function will look somehow like this. I will need the variables here. We will need them later. And also this variable, it's a constant. Let's put it here. I want it to be our map of the chord types. So major 7 chord, 3 additional notes to our root in 4 semitones, 7 and 11, minor 7, dominant chord and half diminished. So how the function works, we call it with the major 7 argument. It creates a new variable where it takes our chord tones. So here the chord type equals major 7, so it will take the chord variable with the major 7 key. This is the array of the chord tones, and then it will create 3 harmonizers with the mic as an input. And for the first one it will take the first element of the list, which is 4. For the second one it will take 7, and third one will take the 11, and it will send it to the speakers. So let's run the code and test it. Now let's sketch the Midi buttons. Pio has triggers. Triggers run the function when event is happening, the same way how the web browser works with events. So let's create a trigger that will react on the button press, and we want this trigger to run this function. We don't have the function yet. To make the trigger work, we need to handle our notes first. It's something that catch our MIDI controller signals, and the trigger callback accepts voice. It has a bunch of different things in it, but here we need just a pitch for the pressed button. And for now let's just print it. Look, I'm pressing this pad, and I know that this pad equals 48. This one is 39. This is 50, and this is 51. Now I can connect pitches and run chord I want when I press relative buttons. Here I don't need print anymore, and I can have this ugly if hell. I will play the note, and then I will press the button of the major 7 chord. And if I will press another buttons, the next chord will override these 3 global variables, and the chord will change. This is major. This is minor. I want to stop the chord when I release the button. Let's implement this. To do so, we will need another trigger function, and this trigger function will have another callback. I just won't stop every harmonizer when this function is triggered. Harmonizer has the special method for it called stop. Let's run the code and test everything. So I'm going to play the note, then I will press the major 7 button, and then I will release it. It works. Harmonica is a pretty high-pitch instrument, and I want chord sound a little bit lower, so that's why I'm going to transpose everything 1 octave down. 1 octave has 12 semitones, and that means that I just have to shift everything 12 semitones. And also I will add a root note. Here is the picture for our map. So we have our root. It will be same note but 1 octave lower. Then our 3 more chord sounds, and same for the every chord type. And here we will need our global variable for harmonizer, and for the function we added one more note, so we will have one voice more here, and also we need to stop this voice here, harm 1, and that's it. Now we can play all the diatonic chords for C major, for example. The only thing that left is to find some cheap foot MIDI controller to press buttons with legs, because hands are usually busy during the play. Alright, hope the video was fun, I wish you to have a great life and interesting projects. Take care.